All right, so let's work on an example of how we find linear factors of a polynomial when we're given a zero. So let's take a look at that. So our example is already set up for us. It says to factor the following polynomial given that it has a 0 at 10 with multiplicity of 2. So what does that mean? As 0 at 10. So if we were to set this whole entire polynomial equal to 0, it would be a polynomial equation. And then if we were to solve it, that means that one of the y variables, one of the y's is equal to 10. It would have 4 answers. So one of those answers would be 10. And actually, due to this term multiplicity of 2, we know that 2 of the answers is 10, right? So we actually just need to find the other 2, or not even find the answers. We're actually told to factor this expression. So we're going to find those other 2 factors. So we know that 2 of the factors are x minus 10, and another linear factor would be x minus 10 because it says multiplicity of 2, right? If we were to set those equal to 0, we would get x equals 10, and that's what they mean by 0 at 10. So I know that these are 2 of the factors. We just need to find 2 more. So we're going to use that to help us. We're going to use our tool of synthetic division, and we're going to take that 10 and we're going to divide it. We're actually dividing x minus 10 into this polynomial equation. By taking that 10, we're dividing x minus 10 into the polynomial here. So the coefficient in front of the y to the 4th is a positive 1. In front of y to the 3rd is a negative 18. In front of y to the 2nd is a negative 3. In front of y to the 1st is positive 1,460. And the constant is negative 6,300. It seems to be going down in descending order. There are no exponents missing, so I need no placeholders. So I go ahead with my synthetic division. All right, in synthetic division, the first number always comes down, positive 1, and we multiply anything below the line times what's in the box, which is times 10. Positive 1 times 10 is positive 10. We write that to the right and up above the line. So 10 and negative 18, add and subtract gives us negative 8. Bring it below the line. Whatever's below the line gets multiplied by what's in the box. 8 times 10, negative times positive is negative 80. Write it up and to the right. Whatever's above the line gets added or subtracted to what's above it. Negative 80 and 3 is negative 83. And then we say, okay, negative 83 times 10. So 83 times 10, that gives us 830, negative 830, right? And we have a positive 1460. So with that, signs are different. So we subtract, and take the sign of the larger number. So that'll be a positive 630. And then we take 630 times 10, and we get 6,300. Positive times positive is a positive 6,300. And look there, we get a remainder of 0. And that should always occur if they're telling us that there's a 0 at 10, meaning that x minus 10 must be a factor. So if it's a factor, that means it must go evenly into that polynomial. And to go evenly, it cannot have a remainder, right? So that's why we get a 0 remainder. So our initial polynomial had the largest exponent of 4. So we drop down 1 to make it, in our answer, y to the 3rd. We can make it 1y to the 3rd, or you and I know that there's an invisible 1 in front of that y to the 3rd. Minus 8y to the 2nd, minus 83y, plus 630. Right, so this is the other factor. And remember, the other 2 factors are x minus 10 and x minus 10. However, we'd like to get all linear factors. So we need to break this down a little bit, right? Factor it a little bit more into linear factors, right? Right now, it's not a linear factor. The largest exponent is a 3, so it's a cubic factor. So let's go ahead and divide 10 into it again, right? And we know we can do that because it said it had a multiplicity of 2 for that 0 at 10. So let's go ahead and input the coefficients of this cubic polynomial. Positive 1 is in front of the y to the third. Negative 8 is the coefficient for y to the second. Negative 83 is the coefficient for y. And positive 630 is the constant. They're all in descending order, so we don't need any placeholders. Nothing's missing. So we go ahead and drop down the 1. 10 times 1 is 10. Negative 8 and positive 10 make positive 2. 2 times 10 is 20. Negative 83 plus 20 is 63. 63 times 10, negative times positive, makes a negative 630. And we knew that it had to work out evenly, right, with no remainder. This 0 represents no remainder because they said that it had a multiplicity of 2. So that x minus 10 is a factor twice. All right, so now let's write our new polynomial that we get from that division. We had a y to the third right above that we divided into. So that means this drops down to 1y to the second plus 2y, right, minus 63. So we know we have that. And we have the x minus 10 and another x minus 10. Still, we don't have all linear factors here, right? We don't have all linear factors because this third factor here, it's a quadratic factor. It's not a linear factor. So we need to go ahead and find linear factors. So I'm going to go ahead and bring these two down, these two linear factors. And instead of doing some more long division, I'm just going to look at it and say, oh, I can go ahead and factor this, right? This is easily factorable. I can say to myself, what times what makes negative 63? And the same two numbers have to add or subtract to make a positive 2. I'm thinking 9 times 7 is 63. So let's go ahead and check our signs. To make a positive 2, it had to be a positive 9 and a negative 7. And let's check, does a positive times a negative make a negative 63? Yes, it does. So we're going to use a positive 9 and negative 7. And we can stop right there because now we have all linear factors, So we've just factored. We've come up with x minus 10 times x minus 10 times y plus 9 times y minus 7. We've just factored that original polynomial of y to the fourth minus 18y to the third minus 3y to the second plus 1460y minus 6300. We factor that into these 4 linear factors. All right, feel free to leave any comments if you need, and I'll get right back to you. Like the video for me, share wherever you need, and subscribe to the channel. Thanks a lot. Take care.